Hey, what's up guys, my name is Cherno and welcome to the 4th Sparky devlog. So, it's been a while since the last one, I'm sorry, I think I'm 3 days late on this one, but it has been a very busy week and I've done a lot of things for Sparky, so this devlog should be pretty exciting. So, I'm actually going to focus on one of the tools that I made for Sparky. Now, this is the first, I guess, official tool that I'm actually using now, and basically it is over here and it's called Spm Build. So this was one of the things that I decided that I needed to do this week because of the kind of more complex things that I was developing. But basically the point of Spm Build is it is a tool that takes in an Fbx file and outputs an Spm file. Now what is an Spm file? An Spm file, it's basically it stands for Sparky model, right? And it is Sparky's model format. Fbx is an Autodesk model format that is used by pretty much everything. The SDK for it is open, so even things like Blender that aren't Autodesk products do support Fbx export. I've heard that it's really bad in Blender, but I don't use Blender anyway, so I don't know. But I'm sure that there's no reason for it to be bad since the SDK is open. So someone just really needs to fix that, I think, if that is still the case. Anyway, the point is that an Fbx file is kind of like, it's pretty much the best, I would argue the best model format, the best intermediate model format, right? So let's just say you're in your 3D modeling application of choice, right? And you have modeled, you know, a resource, an asset for the engine, or an asset for your game, rather, right? Once you do that, you've got a few export options in terms of file formats. Now, OBJ was the one I was using, which is a text format, which is kind of basic. The problem with OBJ is that a lot of OBJ exporters don't export things that I needed, right? So for example, you know, I can get stuff like, you know, vertex positions, texture coordinates, and normals just fine, right? And even like some materials and stuff like that, but I couldn't get tangents or binormals, which I needed. And that's obviously not because OBJ doesn't support that. No, there's no such thing as like OBJ doesn't support something, because it's a text file format. You can just jam whatever data you want in it. But none of the exporters that I was using offered to export those things, which I needed. So Fbx, on the other hand, is a very fully featured file format which supports absolutely everything. Okay. Of course, it does support tangents and binormals. It supports multiple meshes. I mean, OBJ does as well, but that's besides the point. Fbx supports multiple meshes. It supports this whole kind of hierarchy. It supports materials. It supports animation, skeletons. It supports everything, right? So which is why a lot of studios use Fbx as their kind of intermediate format. So this is a devlog, so I'm really not going to jump in too much about how all this works in terms of, I'm not going to explain to you guys how 3D formats work and why you want to use this and not that. I might save that for another video because this is a devlog. But my point being that whilst Fbx is a nice format, it is going to be, it's not the perfect format to use for a game engine. Okay, you can write an importer for it straight into your engine, and that's fine. And you might use that for stuff like while you're working on your game, just because it'll be quick and easy. But when you actually ship your game, you don't want to have something like Fbx because it's not in the format that you want it in, basically. What you want to do is you want to write a model format that is specific to your engine, okay, that has only exactly and only what you need, right? And also in the layout that you need, okay? So the whole point is once we do load something like an SPM file in Sparky, if we go to something like model.cpp, you can see that what happens is we read in the file, right, into a bunch of byte buffers, basically. We read in the vertex data right here. It's just a stream of bytes that are read directly from the file. And then what we do is we, of course, set up the buffer layout for OpenGL, and then we simply create a new, we create a buffer, and then we just set a vertex buffer to be filled with that vertex data that we read straight from the file. So it's already in a perfect format, right? And then same with the index buffer as well. All of that's figured out, yeah? So all we're doing is we're basically copying, I mean, we are doing an intermediate step here. We're copying the entire file into RAM first. But the point is, what we're doing essentially is we're basically taking that file and we're sending it straight to our GPU, okay? that is the gist of this. And because of that, it's fast, because we don't need to pass anything, right? Before with the OBJ model, which isn't actually supported right now, I've just kept the code around. Before with the OBJ model, we were, of course, passing it line by line. And then we had to basically insert vertex, and this did indexing and all of that stuff, which is terrible because the thing that I saw whilst working on Sparky was that it would take me like a second to load a 1 megabyte OBJ model in debug mode, right? And that's actually, I'm not making that up. It would actually take like a second, which is terrible. This is pretty much instant because if it's a megabyte, it's no parsing whatsoever. It's a binary file format as well, which of course means that it's exactly the way we want it. And it's just, yeah. I mean, yeah, that's pretty much the gist of it. I don't want to go too deep into this, but that is the idea. So that being said, if we quickly run through how this works, I put this together based on a few Fbx samples. If you install the Fbx Sdk, it is absolutely free. The only licensing kind of thing that they do have is that you have to disclose that your software uses the Fbx Sdk, which of course I have done. But the idea is that what you do is if you actually install the Fbx Sdk, you'll be able to look at the samples. It comes with a lot of samples, like 20 samples or something, and some of them are fully fledged OpenGL scenes with animation and everything, right? So if you look at that, that will have more than enough information required for you to actually get started with FBX, as well as, of course, reading the official documentation, which just basically outlines how the format works, which is also very important. But basically, the idea is we run the FBX importer. Currently, this only supports... Now, the Sparky model format is very, very, very primitive at the moment, okay? It barely supports anything, okay? The reason is I spent about a day on this. And a day is probably a bit of a stretch because I think it was 4 or 5 hours to write this whole Spm Build tool, as well as an importer for the Spm file format in Sparky. It took me about 4 to 5 hours. So I really rushed this because basically I was about to add normal mapping to Sparky, and I realized that I don't have any binomials and tangents. I didn't want to calculate them myself because that's never good. I wanted to just take them in straight from the mesh. So the idea is... I needed a new file format, and I didn't really want to write a file format on that day, so I was like, I'll just do this quickly. That was the idea. And there are 2 semicolons here. Anyway, I have cleaned it up a little bit since, but it's still very, very messy. So if we go to, if we look at how this works, basically, first of all, it will load the scene, it'll load the root node, and it will basically, if I can remember this, yeah, it'll keep recursing over all of the nodes, and if it finds a mesh at that node, then it will try and add it. It will basically read it, right? Which is what this kind of stuff does. It will read all the necessary details that I want right now, which are vertex positions, of course, or as they're called, control points in FBX. It will read in binomials and tangents, and UVs. And it will insert vertex, which will basically kind of very similar to what we had in the OBJ one, where all it will do essentially is it'll index it for us as well. FBX gives us all of the mesh data not indexed, so we have to do that ourselves, which is fine, especially because it's an offline tool. And that's pretty much it. Like this is the indexing will be very, very fast anyway, so that's fine. Okay, cool. That's pretty much how it works. If you actually want to read the code, then you may do so. But that is the gist of it. I'm gisting a lot here because I'm trying to kind of not keep this devlog going too long. Okay, anyway, the point is we get all of our data. Right now, if we look at, I think it's in here, utils, right? So we have all of our, these are currently duplicated. You can see Vec3 obviously exists in the actual engine, but currently Spm Build does not have any dependency on Sparky. I kind of want to keep it that way because it is a tool. I'll probably have to write some kind of intermediate. I'm not even 100% sure how I'm going to do this, but obviously I don't want to have the exact same vector and maths kind of types defined here that are basically exactly the same, right? Anyway, so we've got all that stuff. We've got the Vertex Struct, which is exactly the same as the struct that you'll find in Mesh. So if you go to mesh.h, there'll be a struct. You can see that it's got basically 2 vec3s, a vec2, and another 2 vec3s. That's the kind of vertex layout. And that's all of our vertex attributes that we kind of support. This has the exact same thing, right? Okay, cool. So that's pretty much it. And then yeah, SPM writer will kind of just write out all of the data. It's pretty simple. And that's yeah, I think that's pretty much it. So what this will do is did I explain everything? I think I explained everything. I'll show you guys this in action now, but basically it's really simple. It grabs the data from FBX and then writes it out into a custom format. That's pretty much it, right? Really basic, really simple, and very, very powerful. So how does this work? Well, very, very simply is the answer to that. Let's just pop into Maya for a second here. So this is Autodesk Maya. This is a pretty popular modeling application. You can get the LT, I think it is, edition, which is like $100 and some. So I think it's like $400 or $300 a year. This is a lot more powerful than Blender. You can also use something called 3D Max, which I used to use quite a lot, and I still do. Those are my two favorite modeling applications. Now, I come from a visual effects kind of background, because I used to do a lot of visual effects back in the day. So I'm very used to these programs, right? Blender, I have nothing against Blender. It's free. If you want to use it, you can use it. I mean, as long as it can export FBX, you can do whatever you want with it. Okay, cool. I'm just more used to these tools, especially because I do work as a software engineer at EA, so we obviously use these tools, not Blender. But the idea is, like, if I create something, this is just for demonstration purposes, if I just create something like, let's create a cube here. I will quickly, whoops, let's come over here. I'll quickly just make it bigger. So we'll say maybe 4 by 4 by 4. I'll make it a bit interesting. I might deform it a little bit. Let's just grab some vertices and I don't know, we'll just kind of stretch them out here. I might just smooth the mesh as well. If I go back to object mode and edit mesh, we could even add some other things like beveling and stuff. Anyway, I'm not going to pretend I know how Maya works because I'm much more of a 3D Max guy. Anyway, point is, if we find the smooth thing, which I was looking for, which was that? Yeah, that'll just smooth it a little bit. Don't even know if that did much. But anyway, we have this mesh. Whoa. How did that happen? No. That looks very weird. Whoa. I really destroyed some things. I must have selected some back-facing. Okay, that looks a bit better. Anyway, this is very, very weird. But we kind of have this thing. Again, if I was in 3D Max, I probably would have just dragged a teapot. Honestly, I'm not sure why Maya doesn't have a teapot available. I mean, every 3D application should. So if we export this, if we just go File, Select, we finished our mesh. If we go File, Export Selection, we go to, in this case, I'm going to actually go to the bin release directory for Spm Build, right? I'll just save it there because it'll be easy. I'll call it something like object. I'm going to export it as an Fbx file. If you go over here into settings, in terms of geometry, we're just going to export tangents and binormals. We don't care about anything here yet. SPM doesn't support materials yet. It will. That just wasn't a priority right now. Any FBX should probably work, I imagine. The Fbx Sdk should support that. All right, cool. So we'll just hit export, and what we should see on disk now is an FBX file, object.fbx, right? So the way that you can build this using Spm Build is pretty simple. If I just open a command prompt, if we type in something like, I'll just kind of downsize this. If we type in something like Spm Build, it'll tell us the usage, right? Which is pretty simple. We specify the FBX file name and then optionally an output file name. So I could just type in something like Spm Build object.fbx, lols.spm or something, and you can see that it will import 189 polygons. That's fine, and then it will kind of spit out that SPM file, right? Optionally, the way that you probably will use this, I imagine, is you can just drag any Fbx file onto Spm Build, and it will just automatically do everything for you. And it'll call it the same name as the Fbx, but it's now an SPM. Cool. So how do we load this into the engine? Very, very easily. So if we go back to Sandbox, for example, resources, I'll pop it into models. I've got a bunch here, and object.spm. We can go back to test 3D. Now this has a lot of stuff loaded up. So maybe if I just remove everything from the scene, because otherwise we won't see anything. So if I just run it right now to make sure that the scene is empty. All right, scene is empty. If we go ahead and we load that in. So how do we load that in? Well, basically all you have to do is you can just do something like mscene.add new entity. So you have to create an entity out of it first. You can specify a mesh. We actually have to load the model as well. So if I say model m, or we'll call it obj, equals new model. So what do we need here? I guess we just need a path, right? We need a path and optionally material. Okay, so the path will be res, what was it again? Res models and then object.spm. Object.spm. We will specify material as well. So let's see, I've got a bunch of materials here that I was playing around with PBR wise. So we'll maybe do something like, what were the materials again? M materials, and then we've got a few. So I think the ones we have available right now, why not? We'll go with something like, yeah, cast iron. So, cast iron. All right. Whoops. What am I doing? There we go. I'll create a new material instance out of that. I'll add the obj, and I don't really care about the transform, and that's pretty much all you have to do. Okay, these two lines. Now this is still complaining. Oh yes, of course I need to get the mesh out of the model. All right, there we go, done. So if we launch this, we should see our object in the game. All right, and here it is. So this looks quite interesting. I must have left the map modified, but anyway, we see this kind of thing with a few interesting polygons here. We see a little bit of a gloss map actually. Let's try something like that red plastic, ABS red. That might look a bit better. Abs red. All right, there we go. So now we've got our model in kind of a red plasticky kind of appearance, okay? But you can see kind of how the how easy it is really. You need to convert that FBX to an SPM, drop it in, and here you see it. Okay, cool. So that's pretty much how the model format works. I'll show you guys the rest of my scene and the stuff that I've kind of been playing around with just for fun. So if we get rid of our little model that we just created and I run it, I'll show you guys around this. So this is the scene that I've been playing around with. Basically, we've got, let's start with the spheres because they're fun. We've got a bunch of spheres here, which basically vary in roughness from 0 roughness or 1 smoothness all the way to maximum roughness or minimum smoothness, right? Same with the plastics here. You can see that we've got a, this just uses, I believe, so another thing is these all use constant values for stuff like roughness and specular and diffuse, like albedo, right? Whereas this plane that you're looking at actually uses a map. So you can see that like the roughness or like how reflective a surface is, right? So the smoothness as well, the gloss, whatever you want to call it. Gloss, roughness, smoothness mean the same things. It's just that roughness is basically gloss or smoothness, or 1 minus gloss or smoothness, right? So you can see that we can kind of create like this kind of puddle looking thing just by adding by creating a gloss map basically. And that's kind of how I've added Cherno here and lols over here and all that stuff. And then we have this kind of gunmetal material here. That's what it's called. And that's just kind of, yeah, Interesting. And I've got a bit of a black specular, which is a bit weird. Anyway, you can see how that works. If I quickly disable the normal map just for fun, it's on my other monitor, doesn't matter. Normal map is now off, then you can probably see the spheres a bit better. So normal map is off now, everything looks extremely reflective. But you can see that, yeah, these spheres, I'll have to move the camera over here. All right, you can see that these spheres kind of do show the varying roughnesses. Okay, cool. We will talk about all of this, and I'll show you exactly how it works next devlog, because that's another thing that I've been working this week, but I want to save that for next devlog because I'm going away, and I don't want to miss a devlog, so I'm going to record 2 devlogs today, but you guys are just going to have to wait till Monday. So have fun with that, but I'm going to give you guys a grand tour of how all this works, and we'll customize it and set up a bunch of stuff ourselves, and that's going to be fun. So if you guys enjoyed this devlog, then please consider supporting Sparky. I am on Patreon. I've added a new reward finally. If you pledge $5 or more per month, you get access to the Sparky Nightly, like put nightly in quotes because it's not going to be daily or anything like that, but version of repository, right? So I'm using a different source control thing called versioner to control, for version control for Sparky, right? And basically I'm going to only push the code to GitHub probably around once a month, maybe less, because I want the commit log on GitHub to be kind of like a release commit log, right? So releases I put on GitHub. What I mean, I don't mean releases by, 0.1, 0.2, stuff like that. Obviously Sparky isn't up to the stage where I can say that this is now an official engine release. All I mean is that when I'm happy that everything in the engine is stable, I will push it to GitHub. Now, you won't get features that I'm currently working on GitHub, okay? Because I really want to keep that kind of public profile really clean. So instead of creating a GitHub branch, instead of creating a branch on Git or anything like that, I'm actually using a different version control system called Versioner. If you want access to that, you can just pledge $5 or more per month, and I'll add you to that, and you'll be able to see all this stuff that I do in progress that is most likely broken. But on the plus side, you will get all this kind of PBR code, and I mean, I'll probably do a release for this very soon anyway. But you'll get all this code that I'm kind of just messing with pretty much every day, right? So if you are a big Sparky fan and you really want to be on the bleeding edge of this development, then this is definitely for you. Otherwise, if you're fine to just sit back, relax, and get stable versions of Sparky, then you can obviously just do that by heading to the GitHub page, where I will push that stuff. You can see that the last time I pushed was like a month ago. So it's been a month of just me doing stuff on Versioner, because I'm in that hectic kind of development cycle now where I'm pushing stuff that doesn't work all the time. You can also keep up with what's going on in terms of Sparky's development by going to the Trello board, which is bit.ly/Sparky Trello. Where you can see that the stuff in purple, for example, is stuff that I'm currently working on. And I try and update this pretty well, right? It's also got a triage kind of thing where stuff that is more red is more urgent, and stuff that is kind of green is like low priority and stuff like that, right? Cool, so that's it. That's it from me. Hope you guys enjoyed. And I will see you guys on Monday with the next Sparky devlog. Goodbye.